I'll offer a hand-wavy proof of the kinetic energy and elastic energy formulas because to do a full-on proof, you'd need some calculus. So, yeah, calculus. We could learn that, or you could just accept my hand-wavy truth. What I'm going to have you imagine is that we're dropping a book from a certain height. And we would normally analyze this with kinematics, right? We could say that the initial velocity is 0, it's accelerating at the constant g, its displacement is h. To solve for the velocity final, we could use this kinematic gem, and we could cancel out our initial velocity because it's 0. Let's hold on to that. Now let's turn over to energy perspective and say that our system is going to be the Earth in the box so that there's no external force acting, meaning that the initial energy will be the final energy. Well, what is the initial energy? If you watched the last video, then you could say, oh, that book is raised from a certain height off the ground. If I call this to be 0, then the potential energy there is mgh. So that's potential energy. If I drop it, because there are no external forces acting, the energy should still be mgh, but now it's just getting converted. So I still have energy final as mgh, but now after falling, it turns into kinetic energy because it's moving faster and faster and faster. So let's solve for this energy final, shall we? We take mgh and we just select out the gh because we have a relationship up here from our kinematic variables that velocity final squared over 2 is equal to gh. So I am going to substitute this in there, and I get the equation mass times final velocity squared over 2 is equal to my energy final, which I define to be kinetic energy, and that's our expression for kinetic energy, 1/2 mv squared. Something along the same lines of a proof, it follows the elastic energy. I'm going to spare you that and hope that you just believe me that the elastic energy expression is 1/2 kx squared. This u, I didn't explain it back in my other video, but the u is what is conventional to express energy. So the potential energy of the spring, us, and for my last video I used ug for potential energy, and that, remember, that was mgh. But back to elastic energy, 1/2 kx squared, where k, remember, is the spring constant, how stiff or stretchy the spring is. The higher the spring constant, the stiffer it is. And x is the distance stretch. So you stretch this thing further, we have more elastic energy. Makes sense, right? All right. Thanks for watching.